Okay, so when we look at curves, they go up forever, down forever. They have no max or min. So what we're going to look at is the extreme value theorem. As long as f is continuous on a closed interval, then we have both an absolute maximum and an absolute minimum. So what that means is I have a line or a curve. I might not have an absolute max or min because it may go on forever. But if I close it and I say, okay, I'm only looking from there to there, or I'm only looking from there to there. If I close it, right, I snip out a piece, then I for sure have to have a max and a min. Does that make sense? So in math, if we provide a closed interval and we say we're only going to look at a piece of this curve, I'm going to snip it, then we have a max and a min. And that has this fancy name called the extreme value theorem. So when you see this in college next year, I don't want you to be frightened to be like, oh my gosh, what is that? That just means if you cut a piece of curve out, there's got to be a max and a min. So let's look at that. How do we do it? To find extreme or extreme values on a closed interval, we find the critical numbers in AB where f, oh, look at this, f prime equals 0. So what does this mean? What is that symbol? Derivative equals 0. So we're going to find where the derivative equals 0. What are we going to have to do before we can figure out where a derivative equals 0? We're going to have to take the derivative. Right? I'm kind of writing your steps down. These are the official steps, but I'm going to write the English version of the steps. So in order to figure out where the derivative equals 0, you'll have to take the derivative. Then you'll set the derivative equal to 0. So let's look. Find the critical numbers, aka set the derivative equal to 0. Then evaluate each critical number. Now, notice this right here. You're finding where the derivative equals 0, but you're going to plug it back into f of x, into the parent equation, if you will. Tell me why we're doing that. Okay, in this unit, when I ask you questions, I'm asking you about the given f of x equation. We use the derivative to answer questions. So it's kind of like I'm talking to you and trying to find out about your parents. Does that make sense? We're going to use the first derivative and we're going to use the second derivative to ask questions about the original, about the f of x. So think about it. I'm asking children and grandchildren about the grandparent, right? Okay. What's next? Evaluate at each endpoint, right? So plug in zeros and endpoints to f of x. The derivative zeros, where the derivative equals 0. The least is the minimum, the greatest is the maximum. Well, I think you can figure that part out, right? So here I've got some nice rules, easy to follow, simple. So what are we going to do first? What is the blue rule? Take the derivative. Okay, very simple. We took the derivative. What are we going to do now? Set it equal to 0. Right? What does x equal? Plus or minus 2, right? Okay, that was number 2. What's rule number 3? Plug in the derivative where the derivative equals 0 and the endpoints. So I'm going to have to choose my x's. Now, where am I plugging them in? F of x, not the derivative. Very important that you make this distinction because we're going to have other tests where we do use the derivative. So you have to know on the extreme value theorem, we're doing mama equation, right? F of x. So I have to plug in the 2 points they gave me. And then what else am I going to check? I'm going to check anywhere that the derivative is equal to 0 that fits between these points. Now I had 2 and -2. Do either of those numbers fit in between 0 and 5? 2. Am I going to check the -2? No. Maybe we better don't plug -2 in. Why? Because it is not in 0 to 5, right? They told us that we were only allowed to look from 0 to 5. So if we get other zeros on the derivative, we just ignore it because it's not in our domain. So if you plug 0 into the mama, what do you get? If you plug 2, we get what? 8 minus 24, which is -16. And if we put 5 in, okay, which one of these numbers, 0, -16, or 65, is the smallest? Here's my smallest. 65 or 0, which one's bigger? So, smallest, therefore minimum. Biggest, therefore maximum. So the maximum is at x equals 5. The minimum is at x equals 2. Now, everybody sees why we're plugging in these 2 points, right? Because if I snip a curve, it might be the highest point. Why are we checking where the derivative equals 0? I want you to make this connection. Why in the world are we setting the derivative equal to 0? That doesn't make sense. Why are we doing that? What does the word derivative mean? No, 5-letter word starts with S.
Slope.
Derivative means slope, right? So tell me, if I'm at a maximum right there, what is the slope? 0. And if I'm at a minimum, what is the slope? 0. That's why we're setting the slope equal to 0. And how do we find a slope? We take the derivative. That is why, make a note to yourself, mins and maxes occur where a derivative equals 0. That's why we have to check any place where the derivative is 0. Does that make sense? This all ties together. We're going to spend, I don't know, we have about 4 days of notes, and it all intertwines and ties together. So we have to make sure the little pieces go in. We'll take it in little packages, but they have to be good. Okay. Is everybody okay with that? Right? Let's write a note. Y'all didn't write it. Why check where derivative equals 0? Because, write this down, because derivative equals slope. Slope is 0 at max or min. Make that connection, write that down. That's a huge connection for this whole unit. We will come back to that over and over again. Isn't this exciting? Super Bowl weekend, you got the extreme value theorem. Woo! Go Bucks, go Brady. Okay. All right, let's try and run through our stuff on the next one. Of course, I put a scary one in. It would be too easy if we just did a polynomial. We need a log. So let's take f of x. What is the derivative of ln of x plus 1? 1 over, right? Now, we're going to set equal to 0, or we had another thing up here. What other thing can we check? Undefined. This is never going to be 0, is it? No, not. So we have to see where it's undefined. Where is this undefined? What makes the bottom 0? Okay, that you just see with your eyes. It's pretty easy. We can't set it equal to 0. We don't have a variable in the top, right? Remember your DH radi? A fraction's not going to be 0 if you have no variable in the top, right? Because in order for a fraction to be 0, it's got to be 0 over a number, and that's a 1. But we can see where it's undefined. Any fraction is undefined if the bottom equals 0, correct? A little bit of algebra back in there. So once we find that, I should have wrote that in green, undefined here. Now we're going to go to step 3. And don't pull out a calculator. You can do this with your eye. So we know we're going to check 2, and we know we're going to check 3. Now, is our number -1 in between 2 and 3? No. So are we going to check it? No. -1 is here, okay, out of, so we don't need it. We do not use it. Remember, extreme value theorem is giving you a specific place to look. -1's out of there. So let's plug 2 in. If I plug 2 into this, what do I get? Go way up here. I get ln. What's 2 plus 1? 3. If I plug 3 in there, I get ln what? 3 plus 1 is 4. Now, I don't know the decimal for the natural log of 3. And I don't know the decimal for the natural log of 4. But can you tell me which one's bigger? 4. This is bigger. This is smaller. So in order to accomplish my task to pick out which is the min and which is the max, do I have to actually know the answer? Just have to know which one's bigger. And remember back to a log, y'all, right? This is move left. It looks like this. And it's telling us between 2 and 3. So between 2 and 3, you know that a log grows slowly, and we know every number that we go to the right is going to be a little bigger. So there we go. Where's the max? At x equals 3. The minimum is at x equals 2. And notice when I ask you these questions, I'm asking you where it is, like when x equals 2 or 3. Are we asking you to find the y value? We aren't. You don't have to find the y value. I just want to know at what x will I find my max or my min. If I need the y, I can then just plug it in and get that out, right? I'd use a calculator. Okay. All right, y'all. Oh, what are those steps again? What do we do first? Take the derivative. Write that down again. See how good I'm getting at this? Because I keep writing it down. What do we do after we take the derivative? Set derivative equal to 0 or undefined. Sometimes we forget about undefined because it doesn't pop up as much. What do I do last? Evaluate endpoints or where derivative is 0 or undefined. Write that down. And I don't know why when mine printed, it gave me little boxes instead of brackets. If yours did that, just fix it. That is an issue of the printer. And I think math equation editor got taken off the computer I used to do this. Of course, you know, we can't have a simple polynomial. We need ease and trig and fractions. Okay, so step 1, find the derivative. I'm going to do my derivatives in blue. What did I just do? What is the derivative of e to the negative x? E to the negative x times the derivative of the exponent. And what's the derivative of negative x? Negative 1, right? Plus, what's the derivative of x? 1. So now we're going to set that equal to 0. Now, you don't need algebra to do this, do you? Just think about this. I want y'all to never freak out when you see the letter E. What I'm giving you, you're going to be able to do with just your eyes. So basically, I could move the E over, right? Let's do that. How do I, what number do I need to plug in for x to make it equal 1? 0, right? Because anything to the 0 is 1. So that was easy. We were able to do it with just our eyes, right? And you could look at this. If I put 0 in for x, e to the 0 is 1, negative 1 plus 1 is 0. Remember, with e's, you're always checking to see if 0 works, right? Especially since I really wrote these to be done without a calculator. You can use one, but they're written to be without one. So they're going to be pretty easy. So now here we go. I always put my endpoints in first, and then I check to see if the number I found fits within that domain. Does 0 fit in the domain? Yes, it does. There we go. So let's plug negative 2 in. Now don't go looking for a number, just plug it in. What do you get when you plug negative 2 in up here? E squared, right? Because it's the opposite of the negative 2 minus 2. And just leave that alone. You're not going to need it. Now plug 0 in. E to the 0 is what? 1 plus 0 is just 1. Now let's plug 2 in. That's e to the negative 2 plus 2. Now, which one of those is the biggest number? This is e squared. Now, you can use a calculator if you want, but I just want you to try to think through it. E is like 2.7, blah, blah, blah. It's a little smaller than 3, right? So is that bigger or is this bigger? What's e to the negative 2? That's 1 over e squared. So this is a little tiny fraction, right? So is a little tiny fraction plus 2 going to be bigger or smaller than e squared minus 2? This is kind of like 8 minus 2, right? So that's like 6-ish. So which one's bigger, this one or this one, top or bottom? Top. Now, if you're too nervous to do that, are you allowed to plug that in your calculator and see? Yes, you can. Bigger. Go ahead and plug it in so you're comfortable. It's about 5.389, roughly. But in your brain, think about the fact that e squared is a little less than 3 squared. Now this one is going to be 2 plus a tiny bit, and that one's 1. So which one's the smallest? Yes. This one here is 2 plus a fraction. So 2 plus a tiny bit. So we have a max at x equals negative 2, and we have a min at x equals 0. Is that okay? These aren't bad, are they? Like today's lesson is easy. Your scary part comes from some old algebra, doesn't it? I know you're scared of those logs. All right. Oh, no, not trig. Okay. What is the derivative of 2 cosine x minus x? What's the derivative of 2 cosine x? Negative 2 sine x. And what's the derivative of x? There we go. Found the derivative. Now we'll set it equal to 0. Now we can solve this, right? 1 equals negative 2 sine x. Negative 1/2 equals sine x. So what does x equal? First of all, sine is negative in the bottom. It's a pi over 6 family, right? So you need to know the names of the families down here that are pi over 6. What are they? 7 pi over 6 and 11 pi over 6. Now, where am I allowed to look? I'm allowed to look between 0 and 3 pi. So that's right here. So I don't need that one, correct? So we're going to have x and f of x. And we're going to look where they told me 0, 3 pi over 2. So always put your endpoints in, and then any 0 that you found for the derivative that fits in this domain. And for us, that's 7 pi over 6, yes? Now we go plug them into the original. What's cosine of 0? 1. And 1 times 2 is 2. That one was easy.
That was easy.
7 pi over 6. What's cosine? I'm going to write this one down. What is cosine of 7 pi over 6? Well, it's down here, so it's going to be negative, right? That's a 30 degree, and cosine of a 30 degree is what? Square root of 3 over 2. So it's negative square root of 3 over 2. So what is that? These cancel, and I get negative square root of 3 minus 7 pi over 6. I'm just going to leave that. I already know that 0 is bigger and this is smaller because it's all negative, right? So I just have to look at the next one. What is cosine of 3 pi over 2? 0 minus 3 pi over 2 equals negative 3 pi over 2. So which one is the biggest? Yeah, this is the biggest because it's positive, right? So I know I have a max at 0. Now, which of these is more negative? This is like 1.5 pi, right? And this is, if you need to type them into your calculator, go ahead. But that's negative square root of 3 minus 7 pi over 6. Which one's bigger? Or which one's smaller? Yes, smaller. Like I said, if you need to plug 3.14 into your calculator, you could kind of think about that as what, negative 9/2. This is 21 over 6, and then you got this. So if you're iffy on that, feel free to plug that into your calculator and see which one's actually smaller. Are these okay? Not bad, right? Do we have a system? Take the derivative, set the derivative equal to 0, then plug your endpoints and your zeros into the original to see which number is the biggest or smallest, right? That's all we're doing. Okay. All righty. Of course, now I have to scare you. What is the derivative of this critter and what do I have to use? What rule do we need, people? Is it fair to say that in our work coming up through these problems, you may have to use the chain rule, the product rule, or the quotient rule? Besides the power? Yes, it could happen. What's the chain rule? Bring 2/3 to the front. Subtract 1. What's 2/3 minus 1? Negative 1/3 times, right? The derivative of the inside. What's the derivative of x squared minus 4? Right? Let's clean this up. We can't see it right now. It's very difficult to set that equal to 0 because you can't see stuff. So I'm going to clean it up. First of all, what do I have in the top? 2 times 2x is 4x. The 3 is in the bottom. and this is in the bottom, the cube root of, if you put that in the bottom, you can instantly see what's going to make the bottom 0, right? So tell me what would make this 0 and tell me what would make it undefined. Set the top equal to 0. Where do we have a 0? What makes the top 0? 0. Now, what would make the bottom? The bottom we put to 0, which makes it undefined. What two numbers can we not use here? 2 and -2. So we have found our critical points. And I want you to always, if you get nervous at these problems, kind of think if I wrote them, I made them to be taken without a calculator. So will your eyes just see it if you think for a second? Okay. Well, I forgot to change colors. I'm just going to go with it now. So I always put in what they gave me, which was -3 and 3. And now if any of these numbers fit in there, I'll check them. Do they fit in? Do they? They all fit, don't they? So now we need to go plug those in. So plug -3 in. Are you going to get the same answer for 3 and -3 since it's x squared? Yes, so we have half the work now. 3 squared is 9. What's 9 minus 4? 5. So we have 5 to the 2/3, which basically means the cube root of 25, right? This is the easiest way to write it so that you can mentally figure this out. Let's plug 2 in. 2 squared is 4. 4 minus 4, 0. 0 to the 2/3, 0. Now let's plug 0 in. We got 0 minus 4 is -4, but what's -4 squared? So this is the cube root of 16. Now, where are the minimums? This is a positive number, and a positive number. So does 0 have to be the smallest? Okay, so that's got to be our minimum. You can write plus or minus 2 if you want to. Now the maximum. What is bigger, the cube root of 25 or the cube root of 16, right? Plug it in and see. Now 3 cubed, well, you plug it in. Which one is the max? Okay. You have 2 ways. You can do 25 to the 1/3. Whoops. Oh, I hit the wrong button. 25 to the 1/3. Or you can do math and go to cube root, see number 4. And we can go math for, which one is bigger, the cube root of 16 or the cube root of 25? Okay, so bigger. So plus or minus 3. If you're curious as to what this little guy looks like, you don't have to know what he looks like, but I'll show you why this looks the way it does. That's what that little guy looks like. So we're going to continue to go up forever, but out here at 3, we've hit a maximum. Okay. Does the extreme value theorem make sense to you guys? I want you to know that word. So when you see it, someone says use the extreme value theorem, you won't be like, what? That just means plug the endpoints in any slopes of 0 in, right, or undefined. Now, I want you to go back and play for a second and use your calculator. Here's f of x. What's f prime of x? right? What's the derivative of that guy? Right? It's what? X squared minus 2x minus 3. So I want you to take a second. If you have colors, graph these in different colors. If you're watching the video, I'm going to pause it so you have time to graph it, and then you could start. No. Sorry, y'all. Okay, so what I want you to do is look at these things. So when you look at the picture you graphed, where do the relative max and min of the parent, that's f of x, occur? Where do you see a max? On the green equation here, f of x, where do you see a maximum? You should see one at x equals -1, a max, and a minimum at x equals 3. This really segues us into the entire rest of this unit. Now, for what values is the derivative equal to 0? So that means the turquoise one, where does this one equal 0? And what do you notice? So what do you notice about the max and min of the big one, the f of x, and where the derivative is 0 or undefined? What's true about the numbers? They're the same, and we kind of figured that out already, right? Because we said wherever the derivative equals 0 has a 0 slope, that's a max or a min. For which values is the parent increasing? So look at your graph, and where is it increasing, right? It's increasing from -infinity to -1 and 3 to infinity, right? Everyone sees that. 0 to -1, 3 to infinity, and then -1 to 3. What's happening from -1 to 3? Whoops. It's decreasing. So where is the derivative positive? And by positive, when you're looking, we mean above x-axis. Where is the derivative above the x-axis? -infinity to -1 and 3 to infinity. So what conclusion can you draw? This is a huge connection right here. Wherever mama equation is increasing, the derivative is positive. Be nice to know that, wouldn't it? So if you see a positive derivative, you can go back and say mom was increasing. Where, for what intervals is the derivative negative? That means below x-axis, and that's from -1. Whoops, I keep getting ahead of myself. -1 to 3. Okay, so let's summarize that. A relative max and min occur when the derivative what? Equals 0 or undefined. The mother is increasing when the derivative is, and it's decreasing when the derivative is negative. Positive means above, negative means below. Now tell me, and then I'll let you get to work, why do I care? Why do I care if I'm wanting questions about the parent equation? Why don't I just look at the parent equation? Why do I care? Why am I looking at the derivative? Which one is easier to work with? The equation of the parent or the equation of the derivative? Look at them. Here's your equation, here's your derivative. Which one's easier to work with? The derivative, it's down a power, right? So if you can look at the derivative and answer questions about the parent, didn't you just lighten your workload? You did. And that will bring us to an end. So your homework is listed on Canvas.